Good afternoon, everybody. My name is Nelson Lafreniere, and with me today are
Teresa Stoutsbury
and Kimberly Nugent.
And we are representing the Forensic Science program at Ontario Tech. We wanted to have a chance to tell you about what we're doing in terms of education and research here. So first and foremost, welcome to Ontario Tech University. We are no longer the University of Ontario Institute of Technology, which, as we all know, is quite a mouthful. We have rebranded, and we are now Ontario Tech University, or Ontario Tech. Rolls off the tongue a lot better, I think. But even though we have a new name, we're the same great program. We're doing the same great things here with the additional benefit of a few new faces. So let's just introduce the team here. So we have Dr. Helene LeBlanc, we have Dr. Cecilia Hagman, and we have myself, Kimberly Nugent, and a new recent hire who is also with us right now is Dr. Teresa Stoutsbury. And so we're very excited. In terms of laboratory technicians, we have Stacy St. Marie, who's been our longtime lab tech, and we have a new recent hire, Dr. Jenna Comstock, who is is another laboratory tech with a focus on chemistry. And then, of course, we have our sort of extended Ontario Tech family with Dr. Michael Corbett, retired Detective Constable David Robertson, and Liam Hendricks. So we have a wide variety of expertise here, and so we're doing a lot of good things at the university. And so today we're going to talk a little bit about three major aspects. We want to tell you a little bit about the undergraduate program. Then we're going to talk to you about some grad studies, and then finally highlight some research activities that we're currently doing. So first, let's talk about the undergraduate program.
So as most of you know, we've been around since about 2005, 2006, and we had our first graduating class in 2009. Our program is a 4-year undergrad degree, and our students graduate with an honors Bachelor of Science. It's very much an applied science. We do have 3 specializations, which I'll mention on the next slide, but we apply the science to forensic science, whether it be biology, chemistry, physics, computer science, just to name a few. It's very much practical, a lot of hands-on learning with our state-of-the-art facilities, and we're also FEPAC accredited. We just went through our second recertification, so we're pretty proud of that as well. I mentioned the specializations. So our students have the option after second year to further specialize, or in other words, take a few extra courses to concentrate in either biology, chemistry, or physics. So in chemistry, for example, they can choose to take instrumental analytical chemistry in addition to fire investigation, which is one of our 4th year courses. And this will help hone or provide a little bit more expertise or concentration in that area. Some of our core courses, which all our students take, include crime scene science, criminalistics, and those two in particular are of particular interest to our students. So after first year is done, where they've learned all the basics, we try and then get them into the lab, into the crime scene house to start applying that knowledge. So crime scene science is very much the science of the crime scene. How do you approach a crime scene? What is chain of custody? Why is it important? A lot of documentation, a strong emphasis on forensic photography, and then taking elements of that back to the laboratory, and what does that mean? In 3rd year, we then ramp that up with a course called Criminalistics, and that's where we really develop more complex crime scenes for the students to investigate over the course of a month. And then we start integrating that with laboratory examinations and expert witness testimony. The students are subpoenaed and they need to testify on one of the cases they worked on. So that's just a taste of some of the content we offer our students.
And also within the FEPAC sort of guidelines, we, even though we maintain those, we also have some flexibility to introduce some new courses for students. For example, in the summertime, we recently launched a assassinations course. So while it's not included in the core courses, just to highlight, we do have the ability to offer our students some other unique experiences as well.
So in terms of facilities, equipment, and instrumentation, what we offer is quite broad. And because we're new, we're quite lucky in that we have new equipment that hasn't reached the end of its lifetime. And we are very well supported by the university in that we have a healthy budget to spend on new equipment each year. Some broad instrumentation and equipment dedicated to crime scene investigations. For example, I mentioned photography kits, team kits. We do a lot of fingerprint enhancement and staining, so along with that comes like the super glue, DFO chambers. We have a laser and forensic polylight flares that we use for alternate light source activities. We just acquired a Faro 3D scanner and the imaging software that goes along with that to recreate crime scenes in 3D. And I don't know if I mentioned it here, but we also now have a Megaspeed high-speed camera we use it for projectile blood spatter analysis to take slow frame rates of projectile behavior in space. Some equipment more dedicated to the natural sciences, biology, chemistry, for example. We have a sequencer to do profile analysis for SNPs. We have real-time PCR and liquid handling extraction robot. GCMS, portable GC to do blood alcohol analysis, a lot of microscopes for trace evidence analysis, in particular a comparison microscope and macroscope, and we also do refractive index of glass. And we also try and marry the old school technologies, the tried and true methods of investigating a crime scene with newer software. And this might resonate a little bit more with this new generation. So for example, blood spatter analysis. We'll do the stringing technique with our students, but have them compare that to software that's out there specific for blood spatter analysis. We also use technology for fire evidence collection, scene documentation, and then various databases, for example, cartridge head stamp guides. And all these equipment and instrumentation obviously are used in our program, but we do work with external organizations and are happy to partner for use of this equipment. In terms of our facilities, I mentioned we do a lot of practical hands-on learning, and we're lucky in that we were the first of the forensic programs to have a crime scene house. Our crime scene house is about 10 minutes from campus, and it sits on the Winfields Farm property, and it's a two-story house, which is quite large. We set up complex scenes in the bedrooms. We also have a lecture room, which is nice, so we can do the practical and the theoretical at the same time. We have a large outdoor space where we do vehicle examinations. We have about 4 or 5 vehicles for that, as well as a large field where we do archaeological and clandestine grave recovery. Now, once the students get to 4th year, they must complete a capstone project. And this is basically an experiential learning opportunity that'll bridge the gap from their undergraduate experience to the next steps in their career. So the traditional routes that you might be more familiar with are the honors research thesis project or maybe a directed studies. So our students have the option to do a research project, and this is where we partner with an external organization, so law enforcement, Canadian Border Service Agencies, Centre of Forensic Sciences, the Pathology Service, and this allows the students to work for about 7 months on an independent project with an external supervisor. Directed studies, on the other hand, this is basically a research project without the research component, and this allows students to really hone their writing skills and dive deep into the literature and focus on one aspect of forensic science in particular. The newest capstone opportunity for our students, and becoming the most popular, is the mock crime scene practicum. This option allows students to investigate a complex crime scene over the course of 4 or 5 months. We have the students work in teams, they report to a case officer, and we try and make it as realistic as possible at the end of the day. What we're finding is students interested in this mock practicum course are those that really want to have to further their career in law enforcement down the road.
What's a really exciting highlight about blending what each of the students have learned in the 3 different capstone projects is that they all come back together in April for our annual Forensic Science Research Day, and they all get to present their results, talk about their experiences, what they've learned. We do invite external organizations and agency members to come, so please come down if you're really interested. Let's switch gears here and talk a little bit about research. I'm going to briefly, for the sake of time, give you a high-level overview of what's going on in terms of our graduate research, and I'll pass the mic off back to Kim, who will talk about some key capstone highlights from the research theses. We have graduate students that take research-based master's and PhD programs. They're not course-based programs, again, just emphasizing that our students do complete research theses. The 2 programs offered for students that do have forensic-based projects include the Applied Bioscience. We do have degree programs, master's and PhD degree programs in Applied Forensic Bioscience. where our students do conduct projects in chemistry, biology, and ecology. More recently, with the onset of my onboarding, students are taking master's and PhD programs in material science. What's great about some of our graduate students is that they do have opportunities, like other programs, to travel internationally and conduct research abroad. Just giving you an example here, on the right-hand side of our slide here is Angela Skopik. She's featured here at the Australian AFTER facility, the Human Taphonomic Facility, conducting research alongside Dr. Shari Forbes. Quite exciting. She should be finishing her PhD shortly from the Applied Forensic Bioscience program. We do have facilities where we often collect data for our research. We do have an ecology and decomposition facility, not humans, at the moment. And again, undergrads and graduate students collect data there. We have the Winfield Farms, we have an Environment Canada weather station, and this is where we collect our meteorological data. One of the most awesome bits about being at Ontario Tech University is we put the tech in Ontario Tech University. We do have access to cutting edge equipment. I'm not going to rhyme them all off for you, but just know that our students are working and gaining firsthand experience with cutting edge techniques. Again, asking a research scientist to talk about research could take all day, but I'll give you the quick and dirty of what's going on. We care a lot about decomposition. In this field, we care a lot about identifying volatile organic compounds and also conducting forensic entomology. So we have a variety of research programs in that. We are also very interested in transfer and persistence, from everything about small chemicals that are transferring and persisting in the air, drugs and toxicology, DNA, blood stain patterns, you name it. We identified trace amounts of compounds, what they are, how much there are of them, and how long they actually stay in the environment. I know these are key research questions that can be quite exciting.
Yeah, and a good example of that, Teresa, is something Cecilia Hagman's working on, and that's the persistence of glass on footwear in the environment.
Very cool. Very exciting work. We do have expertise, like I mentioned, in instrumental analysis. So again, identifying small amounts of compounds, where are they, with high degree of accuracy and precision. We do have expertise in material science, not only characterizing these materials, but how can we build fake analogs? So some of you may have worked with some of our products there. Alongside and kind of complementing the work the slide that Kim talked about in terms of our equipment, we do have a lot of expertise in imaging and forensic physics, primarily around blood stain pattern analysis and projectile motion, whether that's being with ballistics, blood stains, or anything of that nature. From kind of the social science point of view, we do look at applied legal research, and this is really around thinking about the assessment and perception of how evidence is perceived in the courtrooms by a variety of stakeholders. So if you're interested in learning any more, again, outreach to us, and we are always looking for research collaborators.
And then let's circle around to undergraduate research activities. So here I'm going to highlight some of the projects we've worked on over the years. We've been around for a while, so we have quite a few, but I just wanted to highlight some that might be of particular interest. Right this year we're actually continuing a study that was started a couple of years ago in collaboration with Durham Regional Police. And that was an interesting project on enhancing footwear impressions that contain salt residue. So basically finding the perfect silver nitrate concentration and optimal conditions to provide a great visual enhancement of those footwear impressions. We're also doing research on 3D trajectory, so the accuracy and precision of bullet trajectory and the reconstruction events around those. In doing that, we're using our Megaspeed high-speed camera in order to slow down the frame rates to be able to see that projectile in motion. In the past, we've also done some basic examinations and review of different casting materials, so as it relates to the collection preserving of blood fingerprints on fabrics. We also have done projects with GSR, so gunshot residue in open environments, and basically examining the depth comparison between chamber markings and ejector impressions. We've done blood stain pattern enhancement projects, in particular examining clothing that's been washed with and without bleach, and then using luminol and phenolphthalein methods to basically see if those blood stains can be observed after washing. We do the dynamics of BSPA as well. So we're investigating in center of mass and dual phase projectile motion, so that phase of flight piece. And a project that a student's working on this year, again, that has been started a few years ago, was the penetrating capabilities of air guns. So differing BB guns and their velocities and the depth of penetration and analysis of that projectile behavior in space.
One thing I should mention too that's kind of exciting is our university does have a site license to have cannabis and cannabinoids on campus. So that could be a potential interesting project that we're looking for partners on.
And that about does it for us. Thank you very much for listening. I hope this has provided you with some more information about what to expect as part of the forensics program here at Ontario Tech. If you would like any more information, feel free to reach out to us at any one of our social media handles. And if you're interested in applying, please see the following address. Thanks very much.